Welcome to the debate. Today we're examining a skill set that has really become the bottleneck for modern creative and technical workflows, prompt engineering. With generative AI systems like GPT-4 and DALL-E now so thoroughly integrated into, well, everywhere, design studios, legal offices, software development, the act of telling the machine what to do has blurred the lines of contribution. And it forces us to ask a really foundational question. Is the effective practice of prompt engineering fundamentally an artistic or, a humanistic skill rooted in language and context and even philosophy? Or is it a purely technical and scientific endeavor focused on algorithmic management and measurable deterministic outcomes?
And that's more than just a semantic argument, right? It dictates how we staff our teams, how we train people, and ultimately how we measure success in these AI-driven fields.
Absolutely. I hold that effective prompting is fundamentally a creative, human-centered practice. I actually like to describe it as prompt architecture. It's about linguistic artistry and designing meaningful interaction.
And I have to say, I disagree entirely. I think that while the output might be aesthetic or linguistically beautiful, the underlying reality demands that prompting be treated as a purely technical and engineering science. It's a necessity for managing the stochastic, kind of random, and complex systems that large language models truly are.
Look, to be truly effective at prompting, you need a different mindset entirely. One that moves beyond systematic, sort of binary engineering thinking. We are, in essence, designing cognitive structures that facilitate deep human-AI interaction. And that is why prompt architecture, or maybe creative conversation design, is just a better description. The core skill here is linguistic mastery. You have to articulate abstract ideas persuasively, navigating nuance, context, subtext, even human psychology to elicit a desired response from the model. Think of it as a director instructing a highly complex method actor, the LLM, to adopt a specific persona, a tone, and a context for an output. We've already seen that non-technical disciplines are uniquely valuable in this space. Consider statutory construction in law or literary criticism. A lawyer reading intricate IRS code or a detailed contract, they have to grapple with ambiguity, with context, with the implied intent behind the words. That is precisely the skill needed to write a prompt that successfully navigates the LLM's vast, latent knowledge space to produce a precise, non-ambiguous result. When you write persuasively, you're engaging in an artistic medium language, even if the end result is something non-artistic, like financial regulation. Success hinges on human insight, on conceptual clarity, and the ability to manage linguistic complexity.
I'm sorry, but I don't buy that definition of the process. While the surface output is fluent text or a visually stunning image, the underlying mechanism is purely mechanical. And ignoring that, I think, leads to unreliable results. Generative AI models operate by converting text prompts into numeric vectors of embeddings. We're talking about massive arrays of numbers, and then performing discrete, reproducible statistical operations. The moment we start assigning agency, calling the model a creative partner or a method actor, we fall prey to an illusion. And this illusion emerges because we, as humans, just don't intuitively grasp the quadrillions of statistical correlations being processed.
Okay.
Therefore, the job of a professional prompt creator is fundamentally an engineering one. It has to be, because it involves managing the unavoidable stochastic elements, the inherent randomness built into these probability-based systems. Relying solely on poetic phrasing is just a recipe for catastrophic failure in a professional context. True professional prompting requires us to employ technical structures we recognize from traditional software engineering, building complex evaluation systems, testing output against hundreds of test cases, and implementing technical fail-safes. We need context management, response validation, and technical processes like retry mechanization. For example, if a prompt fails to produce a validated response template 100 times, a technical system has to autonomously adjust parameters, not just rewrite the poetry. Our aim is technical efficiency and control, leveraging our knowledge of how LLMs are explicitly non-human statistical tools. Core debate?
I see why you emphasize the underlying mechanics. You are correct that the AI operates based on statistical correlation, not genuine intention or, subjective depth. In fact, many critics argue that LLMs are little more than sophisticated, stochastic parrots, just sampling and synthesizing existing human data. But that statistical mechanism is merely the canvas upon which we operate. Even if the underlying process is deterministic, the act of communication with that system is inherently creative because language itself is the artistic medium.
But is it creative or is it manipulation?
But let me explain. The scientific side of LLMs quantifies the probability equation. That's the statistics you referenced. But the unique human skill lies in manipulating that linguistic complexity. Success is not achieved through numerical optimization, but by understanding how a single word, influenced by context, tone, and subtext, holds a multitude of potential meanings within the model's latent space. A purely engineering approach might generate 10 versions of a prompt based on syntactic structure, but a humanistic prompt architect understands that changing one adjective can shift the entire psychological context of the output. This demands expertise in conversational design and human interpretation, all to achieve outputs that serve the human user's often ambiguous goals.
But isn't that just optimization dressed up in flowery language? If you're trying to persuade a statistical model, are you truly being creative, or are you just reverse engineering a massive high-dimensional coordinate system to hit a specific latent target?
I would disagree. Your definition of creativity here is a bit narrow. The highly evocative and surprising outputs you celebrate are simply a consequence of the vastness of the data and our inability to predict the probability distribution. The success of a professional prompt must be measurable, and measurement is unequivocally a scientific discipline.
If we acknowledge that the AI lacks true intentionality or subjective depth, then the prompt must be technically rigorous to bridge that gap between human subjective intent and machine objective execution. We use the scientific method, testing prompt variations, measuring aesthetic judgment factors against performance outcomes to manipulate that complex probability equation. For instance, creating a prompt that generates reliable financial summaries requires statistical validation that the key figures are present, not just that the text sounds convincing. We have to understand the AI's non-human reality and design systems that control the probabilistic inference to ensure the product is reliable at scale.
That reliability, however, is what frees the human creator to focus on the higher level skill, ideation and conceptualization. Which brings us to the value of the process itself. The conceptual value of prompt creation aligns perfectly with the higher modes of creativity described in the extended creativity framework, particularly the synergy mode. When we offload the tedious execution, the mechanical realization of an image or text, the human is free to focus on pure ideation, on creative risk-taking, and formulating complex intent.
Okay.
This is where we see the art being performed, the articulation of complex creative intent. Whether we're talking about many, personally meaningful insights or professional level contributions that shift a field. The generative capabilities of a synergy level AI expand the cognitive boundaries of what practitioners can conceptualize and execute. For example, an architect can conceptualize 100 complex variations of a sustainable urban plan in an hour. Before, that would take weeks. The art isn't in the syntax. The art is in the conceptual breakthrough that the efficiency enables. The LLM acts as the collaborator, absorbing and iterating on the creative risk the human proposes.
I'm just not convinced by that line of reasoning because it conveniently ignores the necessity of managing unpredictability. In any real-world professional context, that is. While freeing up time for ideation sounds appealing, prompt efficiency and reliability are mission-critical. When the system operates at technical autonomy levels 3 or 4, meaning it's indeterminate and adaptive, like those synergy models you mentioned, you cannot simply rely on creative phrasing and hope for the best.
Sure, but
It demands a continuous, scientific method approach, rigorously testing prompt variations, and building technical systems that ensure the stochastic output stays within acceptable professional boundaries. When you talk about the AI operating in synergy, It means the model is exhibiting contingent agency, adapting its outputs based on real-time cues. We have to measure and control that. Imagine a marketing firm using an LLM to generate hundreds of localized ad banners. The prompts have to include technical constraints, negative weights, to ensure the AI never generates designs resembling a competitor's copyrighted style. This technical rigor of managing the how through measurable systems ensures the professional quality of the what. The conceptual clarity is useless if the system produces an unvalidated, unusable output.
The issue, as I see it, is that the field currently suffers from an overabundance of what I call stereotype engineering mindset thinking. While technical competency is absolutely necessary, of course, you need to know how the machine operates, effective prompting is fundamentally a soft skill, a managerial skill. I compare it to training a highly gifted but sometimes erratic staff member. It relies on conceptual clarity and an empathetic understanding of how humans communicate and, more importantly, how they receive communication. This is why disciplines like psychology, sociology, and moral philosophy must be better integrated. We need to understand not just what the AI outputs, but how its responses are interpreted and valued by the human user. For instance, studies show that while people may not be able to accurately distinguish between human and machine-generated art, they feel certain positive emotions like self-reflection, nostalgia, more strongly in response to human work. Addressing this affective and aesthetic dimension requires a humanistic mindset, focusing on contextual relevance and emotional resonance, not just computational efficiency. We need people who can manage the conceptual direction, not just the code base.
I see why you think that, but let me offer a different perspective. While multidisciplinary input is valuable, of course, the core practice remains anchored in technical competence because the application is technical. The managerial approach you propose requires a technical baseline just to define the constraints you're managing. The ability to recognize when the LLM is being asked to do too much or when, external systems or just plain old code would be better deployed for that task that requires technical judgment.
Right.
Or for performance-focused prompt design, which is the goal in nearly all enterprise environments, you need the technical ability to integrate the prompt into a larger system architecture, often through an API, managing input parameters, token limits, response latency. This is pure engineering structure. The ultimate goal is scalability and reliability. You can write the most persuasive prompt in the world, but if it takes 30 seconds to run and fails 20% of the time because of unchecked stochasticity, it's a technical failure. Engineering excels at imposing the structural constraints necessary to move from a poetic idea to a reliable, professional, and repeatable product. Conclusion. Ultimately, while we have to use human language, our creative medium, as the primary input, the non-human, statistical, probabilistic reality of the AI demands that prompt creation is treated as a technical system.
It has to be managed, measured, and architected with scientific rigor to handle complexity and stochastic variance. The engineer understands that this system lacks consciousness, and so the prompts must be designed to control the probabilistic inference the model uses, ensuring the product is reliable and contextually coherent at scale.
And conversely, I would argue that success in this domain is measured by more than just technical performance or speed. It fundamentally requires the creative skill to imbue the system with human intentionality, nuance, and conceptual clarity. This skill is akin to artistic expression or specialized linguistic expertise. It's about writing persuasively to the model to leverage its vast linguistic archive. And this reminds us that the fundamental goal is always better human-AI communication, ensuring that the technology serves to amplify the human creator's own creative capabilities.
And perhaps this tension is resolved in the most advanced configurations, the synergy and potential symbiosis modes, where human and machine intentionality start to blur, suggest that while human input is crucial, the complexity of that integration demands high levels of technical autonomy.
Precisely. That future of creative partnership suggests that truly transformative results will require mastering both technical constraints and humanistic artistry simultaneously. It's really the ultimate convergence of the architect and the engineer working together to define the future of creation.